So again, we are making sure we write our date, page number, and title, and the learning targets. You are responsible for all blue information on the screen. All that could be asked on a notebook quiz. Also, anything I write can be asked on a notebook quiz. So make sure that you are writing all of these things down. If you need to pause the video to make that happen, you may do so. Also, make sure you're adding this in your table of contents. So you've seen all these symbols before, but just a back up and make sure that we're on the right track. This symbol means greater than. This one means greater than or equal to, less than or equal to, and not equal to. And obviously you know that this one means equal to. Alright, so everything we've solved thus far has given you an answer. For example, I end up with an answer like x equals 4. Okay, and there's a couple different ways to represent those answers. So before we get into inequalities, when you get something like x equals a number, you're getting one solution. That is the only answer that will work for that equation. So x equals 4, that's the only thing that'll work, unless you get infinitely many solutions. So if I was going to represent that, because that's what we're getting ready to do with inequalities, is represent your answer in different ways. This is one way to do it. The other way to, and this is the most common, another way to do it would be like on a graph. And by a graph, I mean a number line. So like here's the number 4. This would be the number 5, 6, 7, and so on. This would be the number 3. And if I'm representing this answer, I would just put a closed circle here and say the answer's 4. Because that's the only answer it could be. If I was going to write it in interval notation, it's just 4. It's like a set notation. Okay, the answer's 4, period. Alright, so the difference between getting something is equal to 4 and something is greater than 4, now we've got inequalities, which means there's multiple solutions. So when we get to our next example, there's multiple solutions like here, where we say x is less than 5. X is small, every number that is smaller than 5. So that's everything all the way up to 5, including 4.99999. So there's multiple answers, therefore you're more likely to represent it in different ways, like interval notation and graphing on a number line. The way I just did it with x equals 4 is kind of silly because x is only 4. So what we're going to do is we're going to act like we've already solved our inequalities, and we're just going to go ahead and represent the solution in interval notation and graphing on a number line. So make sure you get the blue stuff, example 1. And then we're going to talk about an inequality such as greater than or less than uses an open circle when you're graphing. And that's because the numbers are not included in the solution. I also want you to add in here that it uses parentheses. And you'll see what I mean in a minute. So let's start with our number line. All I need from you when you make your own number line is to just have the number that we're talking about here in the middle. So the number that we're talking about here is 5. And then the number to the left of it, which would be 4, and the number to the right of it, which would be 6. The number line goes on forever both ways, but this is enough to represent what we have going on here and to let me know you know what's going on. So one way to represent an inequality and the answers x is less than 5 and to show x is everything that's smaller than 5, you would start at 5. And like I said up here, you would use an open circle. And the reason is because if I wanted to put 5 in here for x, I would have 5 is less than 5. And that's not true. 5 can't be less than 5. 5 is 5. So like if I have $5 and you have $5, I don't have less than you do or vice versa. So this is not a true statement. But when we're representing it on the graph, we're saying it can go all the way up here to 5. Like all the way up here at 4.999 and everything smaller than that. So everything this way. So that's why we use an open circle to show that it goes all the way up here, even past 4. So we use an open circle to show that it goes all the way up there, but it doesn't actually include 5. So that's how you would represent that by graphing. If I was going to represent this in interval notation, I always start with the lowest number first. So basically, it's a lot easier to look at the graph. The lowest number first goes on to the left forever. And the number, or the statement that we would call on the left forever, is called negative infinity. Okay, so if this went on all the way forever to negative numbers and beyond all that, it would be negative infinity. Okay, so that's how you represent it. And then it goes all the way up to 5, which is the highest that it can get. It won't ever go past 5, because that's what we said, it has to be less than 5. And it doesn't include 5, so like I said, we would use a parenthesis. So that's interval notation right here. So let's try that with x is greater than 3. The easiest one to do is probably a number line, because you've probably seen it before. So 3 would be the middle number, and then I want the numbers to the left and to the right. And that's enough. That's a big enough graph. That's perfectly fine with me. And again, it would be an open circle, because 3 can't be bigger than 3. 3 is 3. So I'm going to use an open circle to show, okay, it's this, and it's everything. X is what I'm shading. X is everything that's bigger than 3. So that would be all the numbers going this way. 3.1, 4, 5, 6, 7.5, whatever. Anything that's bigger than 3. So when I go to represent that in what's called interval notation, I would start with the lowest number first. Well, the lowest it's going to go is 3. And it doesn't include 3, so I'm going to use a parenthesis. Then it goes from 3 all the way to the right forever. Well, the numbers keep getting bigger and bigger and bigger. So the number that goes that way forever is called infinity. So negative infinity is on the left because it's negative numbers and they just keep getting bigger and bigger and bigger. And positive infinity is on the right. And again, I'm using parentheses because it's not including 3. Infinities always get parentheses because I can't plug them into an answer. It's not an actual number. So let's try another example. But with this example, we're going to talk about these two symbols. And if you remember, this means greater than or equal to, and less than or equal to. So in that case, we're going to use a closed circle for graphing. And for interval notation, we are going to use brackets. And the closed circle and the brackets are used to show us that these numbers are included in my solution. So for example, if I'm looking at this 6 here, if I put a 6 in this x's spot, 6 is less than or equal to 6. It's not less than, but it is equal to. So because of this line, it includes that in the solution. It goes all the way up to including 6. It just never gets any bigger, like 6.1 wouldn't be an answer. So if I was going to use my number line and graph this solution, I would start at 6. To the left would be 5. And to the right would be 7. And this time I'm going to use a closed circle because it can be 6. I can put 6 in for x because that's true. 6 is smaller than or equal to 6 because they're equal to each other. So then I'm going to shade all the numbers that are smaller than 6 because x is smaller than 6. That's what my answer says. So that would be all the numbers going this way forever. Even negative 100, that's smaller than 6. So I'm going to put an arrow to show it goes that way forever. So then if I'm going to write it in interval notation, again, you start with the smallest number first. Well, the smallest number first is going to the left forever. Well, the number that's going to the left forever, we call negative infinity. And because I can't plug infinities in for x, infinity always gets a parenthesis. The highest it's going to go is 6. It will never go higher than 6 because it says x has to be smaller than or equal to 6. And since it can be equal to 6, we're going to use a bracket to note that instead of a parenthesis, only because of the closed circle and this line underneath. Okay, so for the next one, we're going to start here at negative 4. And the numbers to the left of the negatives, remember the bigger the negative, the smaller the number actually is. So this is actually going to be negative 5. and this is negative 3. That's what it looks like on a number line, because these keep getting smaller. Even though the number is bigger, it's more negative, which makes it smaller. So my answer says that x is bigger than or equal to negative 4, which means it can be negative 4. So I'm going to fill in this circle. And if it can be bigger than negative 4, then that would be everything this way, because I would go negative 3, negative 2, negative 1, 0 is bigger than negative 4, so is positive 1, positive 2, positive 3, and so on. So it would look like this, because it's everything bigger than that. It goes to the right. And if I'm going to write that interval notation, you start with the smallest number first. And in this case, it's never going to get smaller than negative 4, so I'm starting with negative 4. And since it can be negative 4, I'm going to put a bracket there. Remember before in example 1, they could not be those numbers because it didn't have the or equal to symbol. And then it goes to the right forever, which is positive infinity, because the numbers just keep getting bigger and bigger and bigger. And infinities always get a parenthesis because I can't plug them in for numbers. Okay? So now that we know how to write the solutions, we're going to solve some simple ones. So we're going to solve like one-step inequalities. But before you do that, we're going to think back to when you solve equations. And this is probably something you've covered in middle school. But we're just going to make sure we're all on the same page. So if I was going to solve this equation, which we just took a test on, my first step would be to get rid of plus 7. So I would subtract 7. And over here, the only thing left over is x because these go to 0. And here I get negative 2. And my answer is x equals negative 2. And again, if I was going to represent that a different way, I would just say negative 2, negative 1, negative 3. And that's my only answer. And then like my only answer is negative 2. Okay? But we're not going to do things like this when we write an equation because that's just kind of silly. This gives you your answer. So now we're going to solve an inequality. So make sure that you get these down. We're going to solve an inequality. And when we do that, we're going to take the same steps to solving an equation. So if you remember, think back. Can I distribute? No. Can I combine like terms? No. Are all my variables on the same side? Yes. So my next step is to box my variable and get rid of plus 7. Well, in order to get rid of plus 7, I would have to subtract 7. When I subtract 7, this cancels, or goes to 0, and I'm left with x only on this side. And on this side, I get 5 minus 7, which is negative 2. Now, if you remember back in middle school, the sign flips only when you multiply or divide by a negative number. So since I haven't done either one of those things, my sign stays the same, and I am finished. This is the answer to my question. However, I have to represent this answer in interval notation, and I have to graph it. So let's start with graphing first, because in my opinion, that one's easier. So if I started on a number line, I would be here at negative 2. Here's negative 1, because it's bigger, and here's negative 3. And if I'm looking at graphing this, I would say, okay, well, it's an open circle because it can't actually be equal to negative 2 because it doesn't have that line underneath it. It's just less than negative 2. So I'm going to open my circle, and x is smaller than negative 2. See how it's eating the negative 2? That means negative 2 is bigger. So it's going to be everything that's smaller than negative 2. I'm shading what x is. Everything that's smaller than negative 2. So that's what the graph looks like. Now, if I'm going to write it in interval notation, the smallest number it is goes left forever, which is the number or the statement negative infinity. And then the highest it's going to get is 2, but it can't actually be 2, so I have to put a parenthesis. So those are the 3 different answers that could be like a multiple choice. They could give you the answer this way, or this way. You have to know how to do them all. That's why we're only solving simple equations tonight. So example 4, I got to get x by itself, so in order to get rid of minus 6, I would add 6 to both sides. And those cancel. The only thing left on this side is x, and on this side, when I take negative 11 plus 6, I get a negative 5. And I did not multiply or divide by a negative, so this sign is going to stay the same. So this is my answer. But we have to represent it in multiple ways, so we are going to draw our number line first. And this is a -5, -4 because it's bigger, -6. And this one's going to be a closed circle because it says x is greater than or equal to -5. So since it's eating the x is bigger, and because it's or equal to, it's closed, and it goes to the right forever. So when I write it in interval notation, the smallest number it can be is -5, and it's a bracket to show it can actually be -5 because of the or equal to. And it goes to the right forever, which is positive infinity. Alright, we're going to do this last example. We'll make this one example 5 to kind of cut down on time because the notes were a little lengthy tonight. So this is example 5. Can't distribute, can't combine like terms, all my variables on the same side. I could box this variable, but I'm going to have to take that -2 off of it anyway. So I'm going to go ahead and do that. Let's take that -2 off the variable. So how do I get rid of -2? I would have to divide by it. Well, when I divide this side by -2, this goes to 1, so it's just a 1x over here. 12 divided by -2 is -6. Now, I told you before, if you multiply or divide by a negative, then you have to flip your sign. So now, instead of being less than, it's going to be greater than. And this is my answer. So one more time in interval notation and graphing. We're going to start with graphing because it's easier. This is -6. This would be -5. This would be -7. Alright, so we've got an open circle because it's not actually equal to -6. It's just everything that's bigger than -6. So it's open, and it's going everything that's bigger than, which would be this way. Alright, and last thing, if we're going to put this in interval notation, -6 is the smallest it can go, but it can't actually be -6, so to show that, we're going to put it in parentheses, and it goes to the right forever, which is the -infinity. Alright, so make sure that you answer the question and rate the video tonight.